Hello everyone, my name is Marco Almerto from BSCS 3rd year, major in Intelligence System. In this video, we are going to dive deep into the rules and protocols of communication in networking. As we know, a network is a bunch of computers connected with each other, and these computers have the ability to communicate with one another to exchange information. As you can see here in Cisco Packet Tracer, I have a very simple network topology. So what are the rules of communication in networking? We have the main 5. Message encoding, message formatting and encapsulation, message size, message timing, and message delivery. These rules were established to ensure smooth and reliable communication in a network. These rules allow devices to send, receive, and understand data correctly. We're going to use the OSI model so we can better understand each rule. I'm assuming you already have the basic understanding of the OSI model. Now let's proceed with the first one, message encoding. Let's imagine you want to send a picture to one of the computers. Encoding happens in the first 3 layers of the OSI, or the application layer. Message encoding usually converts data into binary so that it can be converted into signal, which then that signal gets sent to a medium such as Ethernet, where binary is represented as electrical signals, or a wireless medium where binary is represented as radio waves. We have another one called fiber cable, where signals or binary is represented in light pulses. Moving on to message formatting and encapsulation. Formatting converts the data in a format in which both the sender and receiver can understand. Remember that this format is agreed upon by both parties. This also happens in the application layer of the OSI model. Encapsulation, on the other hand, puts the data into some kind of container with headers, where additional information is stored such as the IP address of the source and destination. Encapsulation happens in transport layer, where data is broken down and encapsulated into something called segments. These segments then go to the network layer, where it is then encapsulated again into something called packets, with additional headers where the IP address of source and destination is stored. And lastly, these packets move to the data link layer, where it is then encapsulated again into something called frames, with additional headers in which the MAC address of the source and destination is stored. Next is message size. If, for example, we want to send a large data, this data is broken down into smaller pieces. This part happens in transport layer as well, where data is broken down into segments as we mentioned earlier. And these segments are numbered sequentially so that it can be sent in order and the receiving end can assemble it in order. Next one is message timing. Message timing ensures that data can be sent efficiently. If, for example, one of our computer can only receive 10 megabytes per second, it would let the sender know about this so that the sender don't send data too fast that could overwhelm the computer. Lastly is message delivery. Message delivery refers to how we send the data to other computers. And there are 3 options. Number 1 is unicast, where you only send the data to one computer. That is, there is only one sender and one receiver. Number 2 is multicast. Multicast is where you send the data to multiple computers, but not everyone. And lastly, broadcast, where you send data to everyone in the network. And that's the basic rules of communication in networking. Thank you for watching.